Okay, Assalamualaikum semua. Now we go to the next chapter, okay, which is actually chapter 6, okay, which is advanced architecture. Okay. Alright, so this concept is more towards the advanced architecture that will more focus on the overview of the parallel processing and other advanced architecture. Okay, so we can classify the parallel process. Okay, so sebelum ni you belajar processor. Okay, it's one single processor. Okay, even the single processor, they can do some uh, okay, multi tasking. Okay, they can do more than one program, execute more than one program at the same time. So the organization of the computer system can be classified by the number of instructions and also the data items that can be manipulated simultaneously. Okay, so all the instruction, it depends on the number of instruction. It depends the number of instruction and also the data of the particular instructions, okay, that can be used and can be executed simultaneously by the parallel processors. So the sequence of the instruction read from the memory constitute an instruction stream. Okay, so the operation we can perform on the data in the processor can constitute to the data stream. Okay, bila kita buat parallel processing, okay, you have several processes, several processes running. So all these processes, okay, can be divided into several tasks at the same time, and then they can execute all the instruction, uh, all the instructions simultaneously with the data stream that given or execute. So the sequence of the instruction read from the memory constitute instruction stream, and the operation performed on the data in the processor constitute a data stream. Okay, so the sequence of the instructions read from the memory constitute an instruction stream. So bila kita parallel processor, we have a lot of processes, okay, running at the same times. Okay, so we have a sequence of instruction which can each processor boleh execute dalam masa yang sama, and then dan dia boleh perform a data stream for each particular process. So the parallel processing may occur in the instruction stream or it can be in the data stream. So parallel processing ni tak semestinya untuk instruction saja, tetapi dia juga untuk data, kalau kita nak stream data. So macam mana multiprocessor can be organized? Okay, so multiprocessor can be organized in a different way. The first one is the single instruction and single data stream. Ini di mana this instruction will be execute sequentially lah. Okay, one single instruction, one single data stream. Or one single instruction, we have a multiple data stream. Okay, where all the processes can receive the same instruction from the control unit, but it can be operate in the different sets of data. Okay, contohnya you have one instruction, tapi you run a multiple data dalam masa yang sama. Okay, ada juga the multiple instructions or single data stream. So this multiple instruction with the single data stream normally is very theoretical interest. Okay, dia tak pernah di practical or implement okay by the organisation or industry. Okay, so secara teori it can do that multiple instruction with single data stream, but nowadays that not particular really implements, okay, in the industry. So multiple instruction with the multiple data stream, yes, okay, the several program can execute at the same time, and the most multiprocessors come from in this category. So most of the multiprocessing, okay, multiprocessing come for this particular organization MIMD, multiple instruction. You have a several multiple instruction and multiple data stream. Okay, alright. So this is a single instruction and single data stream. One single processor akan execute one single instruction, okay, stream, and then dia akan operate on data and simpan dalam single memory. So this is we call as a uniprocessor. One processor, one single instruction for they operate on the data and store in the single memory. Okay, so in a single instruction and multiple data stream, okay, so you have a one single machine instruction control, which is simultaneously execute the number of processing element on the log steps basis, and each processing element has associated with data memory so that the each instruction is executed on a different set of data by the different processes. Okay, normally this is normally used in the array dan juga vector processing. Okay, so you have a single instruction, tapi this single instruction run on different data set ataupun in a different data string. Okay, so bila tu you set dia and then you run dia in the array processing. So contoh kamu kalau pakai array, so ini is a part of it dalam single instruction of multiple data. Alright, so this is how the control unit. Okay, so each processor kita bahagikan the task to each type of processing unit, and then the processing unit have a different data stream. Okay, so one single data stream tu, okay, dia akan have a run this P1 sampai PUN, dia akan running the same instruction but in the different set of data. In the different of data set. Contohnya processor 1, dia use instruction yang sama tapi dia untuk load data stream data stream yang pertama, PU2 processing unit itu dia akan data stream untuk different set of data stream pula. So dia different. Instruction yang sama tapi dia access in the different data set. Okay. Dalam masa yang sama. Okay. So the multiple instruction with the single data stream normally is a sequence, the unit normally is sequence of data that transmitted to the set of processes, and each processes execute the different instruction sequence. But this one is not clear enough because it cannot be implemented in the industry. Okay, so the multiple instruction and multiple data stream ni mostly people pakai on the distributed memory. Okay. Okay, so we have a set of processes. Okay, so each of processes ni ada dia punya control unit dan juga dia processing unit, and they are simultaneously execute in different instruction sequence. Okay, so PU1 dia ada instruction set dia, PU2 dia ada instruction set dia, PU3 dia ada instruction set dia, and all these instruction set ni dia akan access in the different data stream, and all these will be connected into inter-network connection. Normally, this kind of approach is used by distributed system. Distributed system contohnya adalah dekat dalam clustering, okay, dalam cloud. Okay, kalau cloud dia lagi lebih besar. Okay, dalam distributed system. Okay, alright. So kalau dia distributed system, dia in the different area. Different instruction they perform in the different area, and the different and will be connected, okay, using a network. Okay, so example that use a multiple instruction and multiple data stream ni adalah SMP, symmetric multiprocessing, NUMA, okay, non-unified multiple access system, and also a clustering. Okay, so normally this is used in the distributed system lah. Okay. Alright, so this is multiple instructions, okay, with the multiple data stream. So this each of the process, okay, will share the same memory. Okay, so they share the same memory. Memory dia satu tapi processing dia banyak. So dia boleh execute banyak instruction dalam masa yang sama untuk different data set lah. Okay, there are the different data set. Okay, so this is how the taxonomy of your punya processor architecture. So pada processor ni banyak digunakan antaranya di pada processor ni banyak kita gunakan dekat medicals, okay. Nowadays kita in the AI environment, okay, big data. So big data dia akan pakai towards the processing punya prior processing punya process lah. Okay, sebab dia perlukan data analytic kan. Dia nak analyze data. So bila dia nak analyze data, dia perlukan processing yang tinggi, high performance of computer in order to perform your data in the large volumes. Okay, contohnya macam sekarang ni COVID-19. So bila COVID-19, data untuk pesakit-pesakit COVID-19 di seluruh dunia dia compile, dia compute, and then they analyze, okay, based on country, based on umur, gender, okay, based on the Asian country, based on the Asian country, Asia country, okay, Middle East, okay, American, non-American, so on. Okay, so kita pecah-pecahkan dia. So during analytic, tapi dia gunakan high processing lah. Okay, dia tak boleh pakai processor biasa. So dia kena pakai high processing unit. Okay, so this is how the architecture. Normally kita punya distributed dekat sini. Okay, multiple instruction and multiple data stream ni banyak digunakan dalam single multiprocessing. Okay, so dalam multiple processing, antaranya dia dimain sebagai shared memory. Okay, symmetric multiprocessing, asymmetric multiprocessing which is distributed memory. Nah, distributed memory beza dia ialah dia have multiple processor. Tapi dalam multiprocessor ada certain multiprocessor they share the same memory. Okay, normally dia ni dia pakai local lah. Okay, kalau distributed memory dia pakai loosely coupled system ni, dia normally digunakan in the loosely coupled system. Dia setiap processor ni dia have their own memory and they have their own task. Okay, so dia perform, and normally this distributed will be connected through the different geographical area lah. So for example, distributed memory ni macam Google, okay, Amazon, Azure, Yahoo, Facebook, okay, Google. Okay, so Google ni dia banyak. Okay, server dia, distributed system dia sangat besar. Ada kat di Geneva, ada kat China, ada dekat Brazil, ada dekat US. So all these things are distributed. They are connected in a different geographical area lah. So bila dia nak connect, so dia akan connect through not only a cluster. Cluster ni can be in a local area, okay, local area network. Tapi kalau distribution, okay, cloud dia lebih besar. Dia gunakan inter-network. So dia lagi besar lah. Okay. So distributed is a part of it lah. Okay. So kalau the shared memory ni kita ada symmetric multiprocessing, ataupun the next one is we call a NUMA, a non-uniform memory access. Okay. Tapi dia masih architecture yang sama, multiple instruction with the multiple data stream. Okay, so kita akan tengok, okay, the multiprocessing with the tightly coupled system. Tightly coupled system, kamu kena ingat, they shared memory. They have a different processor, okay, and different processor, okay, they connected through the local area network sometimes, okay, and then they share the same memory. Okay, they share the same memory. So the process are shared memory and they communicate via the shared memory. So bila instruction dia nak fetch data, dia akan fetch data dalam main memory yang sama. Okay, bukan dalam memori yang berbeza. Sama juga bila input output dia nak hantar data ke main memory, so proses dia akan hantar in the shared memory. Okay. Alright, so this is how the configuration, how they organize dia punya okay, symmetric multiprocessing. So you have a processor, multiprocessor. It depends berapa banyak processor you have. Okay, and then so you share, okay, among the processor in the shared bus, okay, and also you share with the main memory. So one memory will be shared among the processors, okay, the shared bus, termasuk you punya input output system lah. Okay, that's why dia kata tightly coupled system. So they're very tight with the couples with the system. So, okay, so this normally symmetric multiprocessing can be a standalone computer with the following characteristic lah. So boleh tak dia dalam different machine? Boleh. Tapi biasanya symmetric multiprocessor dia dalam standalone computer, tapi dalam tu dia ada banyak, dia have two or more similar processors. So normally yang ni dia banyak guna on the server. Kalau personal desktop pun boleh, tapi tak banyak. So you kena combine the different processor pula kan. So yang ini kita biasanya dia dalam satu computer itself with the two or more similar process, okay, and then they share the same memory and also input output, and they connected through the bus, okay, macam kita tengok tadi, share the bus and internet connection. So the memory access time is exactly approximately the same for each processor. Okay, macam mana access time for each of memory untuk bagi setiap processor? Biasanya dia akan leverage, okay, dia akan fairly assign, okay, for each type of processor. So all processor juga selain daripada memory, dia juga share the same input output. Okay, so the input output, whenever the input and output will be connected to that particular machine, it's been shared among the all processors. Okay, so all processors can perform the same function. Boleh, they can have a same function we call a symmetric. Okay, symmetric, sama. Okay, the task untuk processor 1 sama dengan task processor 2, sama dengan task processor 3. Okay, the system akan control by the integrated operating system. So is who's being controlled. Yang ni nanti you akan belajar dalam part 3, which is the principle of operating system. That's why benda ni kena ambil main peranan kerana benda ni akan digunakan balik dalam konsep ini, architecture ni akan digunakan balik dalam operating system. So the interaction at the job or task and the file and data element level. So dia boleh control. Okay, operating system akan control dari segi nak assign task bagi setiap processor, lepas tu berapa banyak file yang ada dalam setiap processor, berapa banyak data yang diperlukan bagi setiap processor. Semua kerja tu bukan processor yang buat, tetapi operating system yang akan manage. Okay, normally this kind server operating system can have a capability on doing a symmetric multiprocessing. Okay, apa kelebihan SMP adalah dari segi performance. Okay, so bila you have more than one processor running at the same time, you can see that your punya performance of the computer are much better. Dari segi availability, kalau satu processor is fail, so another process, dia tak boleh halt the process, okay, the machine, tapi dia boleh continue the functions. Okay, but they reduce the punya performance lah. Katakanlah processor 1 rosak, so tapi processor 2, 3, 4 dan seterusnya boleh take over the process, okay, and then they make the system become slow lah, dia tak akan fail lah. Okay, that's why the availability is high, okay, dalam symmetric multiprocessing. The third one is the incremental growth. Incremental growth means it can enhance the performance of the system by adding an additional processor. So you boleh tambah banyak processor kalau you rasa macam you ada kemampuan untuk tambah the processing, so you boleh tambah kemudian. So that is we call incremental growth, okay, and scaling. So dalam SMP they able to do some scaling di mana your vendor can offer the range of products. You can use different products, okay, at the different price and the different performance characteristic based on the number of processors that you configured in the system. So you boleh guna yang ini processor Intel, yang ini processor Motorola for example. Tapi biasanya kita pakai sama lah. Okay, mungkin dari segi scaling ni mungkin you pakai processor, different processor, so tapi untuk different software and application lah. Okay, you dedicatedkan lah, okay, untuk particular ni. So next one is that one is lebih kepada tightly coupled system. Okay, so another example distributed memory, another architecture of a processor adalah clustering. Okay, so clustering adalah part of distributed of memory di mana you can have several of computers, okay, that work together as one unified system, as one unified resources, okay, that create the illusions of being one machine. Okay, you can clusterkan dia, you kumpulkan dia menjadi one particular machine. Jadi dia whole machine yang biasa, okay, personal computer atau desktop tu, you can groupkan dia, okay, you can groupkan this kind of machines, okay, and then connected through the network, okay, macam ni, contoh dia connect to the switch, dia connect and then kita akan one will become a server ni akan jadi server operating system biasanya boleh buat, and then you clusterkan this one it will become into one cluster, one group tapi dia assume as a one machine. Okay, so biasanya cluster ni kita banyak guna untuk internal, for testing. Okay, so the cluster can have 10, 100 or even thousands of machines which is can use as a multiprocessor. So the different purpose from the general purpose of business needs such as the web service to computation intensive scientific calculation. So banyak cluster ni banyak digunakan for scientific calculations, okay, nak buat ada big data punya calculation, distributions and so on. So kita boleh gunakan part of it as a clustering. Okay, dalam clustering architecture ni dia ada 3 types. Okay, one is high performance, high availability and also the load balancing. Okay, 3 element lah. Okay, dalam cluster. One is the high performance. Okay, they have a high availability. Of course, the load balancing. Load balancing means dia boleh bagi task equally or co-balance, okay, by each of the machines. Okay, so each of the machine ada will be assigned the same task, okay, ataupun the different task tapi the load dia sama. So we call a load balancing. Okay. So cluster is one of the example dalam distributed memory ataupun we call a loosely coupled system, di mana they can collect of independent the whole unit processor or SMP and using we call as a node. So dia akan setiap cluster ni akan interconnected, okay, with through the switch or through the network and work together as a unified resources. So dia kena satu one machine will become a master, okay, to create the whole illusions of the machine and to become one. So the communication normally in the network connection, and so the of course dia punya benefit dia banyak. Antaranya ialah they can absolute have a scalability, okay, and then can increment the scalability. You boleh tambah je berapa banyak cluster you nak at the same time. High availability and the superior price versus the performance, okay. So lebih mudah lah kalau you nak jimat, you tak ada duit untuk buat yang besar-besar like a distributed, you can use a cluster is a part of it for the internal use or for the local use, okay. So kita clusterkan, dijadikan satu machine, groupkan dia menjadi satu one machine in order to do the processing. Okay, so this is how the cluster computer architecture. So normally clustering banyak digunakan dalam medical, okay, banyak digunakan dalam computational maths. So macam contoh dia nak buat encryptions kan, proses-proses yang lebih kepada processing. Okay, dia lebih kepada high processing, so kita akan gunakan cluster lah internally. Biasanya internally kita boleh pakai cluster, tapi kalau you pakai untuk connect through the network, internet, so it's not recommended to using a cluster. Okay, so cluster ni is a middleware lah. So dia kena ada satu software. Biasanya operating system boleh mampu do a clustering middleware, and then you have a workstations, okay, that connected through the network, and then they do some parallel processing, and then the programming you boleh set program set of instruction what they need to do, how they need to do, and you assign the task equally, okay, between the processes. Okay, alright. So what are the benefit of the cluster organization is high speed, high processing speed, high performance of computer, offer a scalability, okay, and provide high availability of resources, okay. It can be provide a backup system in the event of the failure of the system. Then the processing power is cost effective compared to mainframe. So processing power dia kurang lah. It's very cost effective compared to mainframe. Bila mainframe dia pakai banyak. And the drawback is high cost to implement and to maintain it. Okay, bila you clustering, so ada 2-3 yang akan rosak, so you have to do some maintenance. Okay, apa beza cluster and versus SMP? Loosely coupled system dengan tightly coupled system, sebab SMP represent as a tightly coupled system and cluster will represent as a loosely coupled system. Example of loosely coupled system. So dua-dua persamaan dia adalah using multiprocessor, okay, with the high demand application. Tapi apa beza cluster dengan SMP? SMP dia control, easier to manage and also control. Yang cluster ni dia susah sikit nak control, okay, and they are closer to single processing system, okay. So dia mungkin dari segi scheduling dia akan will be have the main difference but less physical space and a lower power consumptions, okay, because you have run the different processes running at the same time. Kalau clustering diperlukan ruang, okay, sebab you physically allocated that particular machine or as a node, and then you are connected all as a 10 PC ke 100 PCs tu become in the network and become as one cluster. So the superior incremental, okay, less cost, okay, dia lagi satu dia boleh jimat untuk do some performance of the computer. Superior availability, of course, okay, you boleh available, ada redundancy, sebab apabila satu machine, okay, dia proses, dia execute one program, dia akan make a copy to another machine, okay, to be as a backup, okay, as a backup. Then we call a dan C. Okay, this is a non-euphoma. Non-euphoma adalah contoh uh, tightly coupled system, okay, di mana dia are multiprocessing tapi they share the same memory. Okay, non-uniform memory access, di mana all processor can have access to all parts of memory and all the access time of the processors are different depends on the region of the memory. So bila kita dia step processing time of setiap processor tu akan berbeza, dia berikut kepada ruang the memory area that being used by each particular process lah. Okay. So what is the cache coherent? Oleh kerana processor boleh they can uniform, different multiprocessor can be uniform as one. So therefore the cache also can be against as the coherent of the NUMA. Cache coherent is normally maintained among the cache of the various processors. So setiap processor dia ada cache. So this cache is be maintained and can be used significantly dalam SMP dan juga cluster. Tapi the cache coherent for SMP and the cluster will be significantly different because dari segi the way the architecture of the SMP and also cluster also different. Kalau SMP dia processor dia akan simpan data and they share the same memory. Tapi kalau cluster dia akan use a different processor not share the same memory. So the SMP has a practical limit to number of processor. Walaupun SMP ni boleh digunakan for parallel processing, okay, tetapi they have a practical number of processor. In the cluster, each node has own memory. Okay, kelebihan dalam clustering distributed memory sebab they have setiap processor dia ada dia punya own machine. Okay, so the application do not see as a large global memory and the coherent will maintained by the software and not the hardware. So you boleh mudah maintain it using the software instead of hardware. So the NUMA retain the SMP flavor while giving the large scale multiprocessing. So NUMA ni dia remain SMP juga tapi dia lebih kepada large scale of multiprocessing. So objective dia adalah to maintain the transparent system in the wide memory while retaining the multiprocessor node and each with its own bus or internal interconnection system. So objektif dia memang mudah dan jelas bila kita pakai multiprocessing. Okay. Okay, this is how the NUMA is being organized. Okay, so this is one class, one of unified system. Okay, ni tightly coupled system. So 1, 2, 3. So each of these are shared the same main memory and they are being connected into a network. Okay. So architecture sama macam shared memory tetapi is being they share the same memory and tapi they be interconnect with the network. Okay, apa kelebihan dan kekurangan NUMA? Antaranya ialah the performance lah. Okay, of course they have a high level parallelism than the SMP and not every supportive of not all can support for that particular software. Okay, and the performance can break down is too much when you access the remote memory. When you are terlalu amat access to the remote memory, so it can be it can become a breakdown. The performance of the system can break down. Okay, it can be avoided by apa yang kita boleh elakkan adalah supaya performance dia cannot break down ialah dengan provide the L1 and L2 cache in designing to reduce all the memory access. Okay, kurangkan letak L1 and level 1 and level 2 cache bagi setiap processor so that it can reduce the number of access time for the processor to fetch data from the memory. Okay. The good temporal of the quality of processor. Okay, and it's not transparent. Okay, so the page location, the process location, and the load balancing can change and be difficult. Okay, so apa yang kita boleh nampak adalah dalam chapter 7 last chapter of the for this semester, kita akan nampak different it happens when the advance of the technology of processing has been invented dengan you can allow for multiprocessing dalam single processor. So bila dah ada single processor have running in different one single physical processor can run multiple processor dalam masa yang sama, so they have a possibility of computer performance you tinggi. Okay, dan juga cara macam mana is being organised, okay, by the parallel processing architecture. Sama ada dia menggunakan SISD, okay, uh, MISD ataupun multiple instruction with the multiple data stream, okay, ataupun dia pakai SMP ataupun dia pakai NUMA. So dia bergantung kepada bagaimana the computer system architecture is being organized whether within the organisation. Okay, so that's all for the advanced architecture, sebab you boleh tengok video kawan awak lah, okay, for the project.